Hey guys, we're going to talk about parallel circuits. We have been doing series circuits. Hopefully you guys are doing well in series circuits. Um, Parallel circuits is a little bit different. Remember that in a series circuit, there's only one path for current to flow. We're going to find out a little bit different about parallel circuits this go around. Ohm's law is going to stay the same whether you have a parallel circuit or a series circuit, but we have a different set of rules for a parallel circuit. Um, Rule number one, the voltage drop across each branch is equal to the source voltage. That word branch there is a new word that we're going to have to deal with a little bit. We'll talk about that when we have a picture in front of us. But you notice that a voltage in a parallel circuit is the same on any branch. That's like in your house. Every receptacle in your house has 115, 120 volts on it because they're all wired in parallel, where in a series circuit, your voltage is divided up between the loads. The total current is equal to the sum of the branch currents, and the total resistance is the reciprocal of the sum of the reciprocals of each individual branch. Those are your three rules. I'm just going to leave that resistance thing hanging there for a little bit. It sounds like it might be a little more difficult. We're going to dedicate a whole video just to that, not this one. We'll talk about it a little bit as we go through, but I don't want that to slow you down from getting the basics of a parallel circuit down pat. We will talk about that and learn the easiest ways to actually do this formula, okay? So don't fret on that one. We talked about the current, but just remember that a parallel circuit has more than one path for current to flow. You notice that we have our battery here and the current is flowing through here. Now when it gets here to this branch, remember that word branch? It gets to this branch, it has a decision to make. Do I go this way or do I go this way? Well, these resistors are going to decide how much current goes each direction. What actually is going to happen is some's going to go this way and some's going to go this way. And it gets down here, it's going to have to make that decision again. Some's going to go this way and some's going to go this way. And as the current flows around the circuit, it's going to join back up with the current that went this way. They're going to join back up together, come down through here, and all those that came from out here in the back are going to join up with the guys that went through the first resistor, and all of them are going to be going back through here. We don't lose any current, just like in a series circuit. Now they divide up as they go through the circuit, but whatever here it shows 3 amps being used by this circuit, 3 amps is what's coming back. You don't lose electrons. Now, when we have more than one path for current to flow, the size of the resistors, it makes a difference. But this is our formula for total current in a parallel circuit. Your total current equals the sum of all the currents in each branch. So that's rule one. We talked about that rule here just a little bit. Total current is equal to the sum of the branch currents, and there's a mathematic formula for that. This is a drawing. This is a panel maybe in your house or wherever you live, or in our room here we have a panel, and the circuit goes out to the receptacle and to the light with a switch, another receptacle, a light with a switch, another receptacle and a light and a switch. All these are in parallel with each other. If you were to take a voltmeter and measure the voltage at this receptacle, you would get 120 volts. And since the voltage is the same on each branch, then this branch is 120 volts, and this branch is 120 volts. Nothing is happening here because the switch is open. But if you were to close this switch, then this light bulb would have 120 volts on it, and it would start working. That's a little bit kind of a better description. We talk about series circuits a lot, and series circuits in parallel. Basic electricity, parallel circuits are prevalent. Most things are parallel. It'd be nuts though to have to decide what kind of a voltage you needed on a light bulb when you went to the store to buy a light bulb, and you go buy 120 volt light bulbs in the house. And electronics, especially in DC, series circuits have their place, and parallel circuits have their place. You know, in a string of Christmas lights, if you just pull a light bulb out, a whole section of your light bulbs will go out. Those are all connected in series. But in parallel, if you take this out, everything else still works. Notice how we've taken the light bulb out of the circuit by opening the switch? These receptacles still work because they're still connected. Now, the voltage drop across any branch of a parallel circuit is the same as the applied or source voltage. You may have already written that down before. You don't need to write it again unless you just are trying to work on your memory skills. But voltage drop across any branch of a parallel circuit is the same. In some places, you may read that word branch as a node. It's right here. Anytime there's two or more wires come together, there's one wire, two wires, three wires are coming together. And that's when you have a branch. Here you have a 120 volt circuit. That means that there's 120 volts on that resistor, 120 on that one, and 120 on that one. When stuff stays the same, it doesn't change. It's easy math, right? There's that parallel thing we're talking about. These are three formulas that tell us what the total resistance in a parallel circuit is. The reciprocal formula, and that is the formula. You'll need to have that written down. When we do our video specifically on parallel resistance, I'll show you a little bit easier formula, but they all mean the same thing. Basically, if you have three resistors in the circuit, you want to take the value of the first resistor, get the reciprocal of it, add it to the reciprocal of the second one, add it to the reciprocal of the third one, and whatever that total is, you're going to take the reciprocal of that total, and that will be the value of the total resistance. I know that sounds really complex. If that just blew your mind, forget about it for now. Just write it down, and we'll deal with it later. If the resistors are all the same value, you take the resistance of the resistors and divide it by the number of resistors. For instance, if you have two resistors and both of them happen to be 100 ohms, so it'd be 100 divided by 2, and your total resistance will be 50. Then you have product over the sum. We don't use this one a lot, but it exists, and I do believe there's 2 or 3 tests and a couple quizzes that will ask you about this. You don't have to use this one, but if you have two resistors, you can multiply the two resistors and then divide it by the same two resistors added together, and you'll get your total resistance. Algebra is a funny thing, isn't it? But this will produce the same thing as this. But I will tell you that this formula here, you have to have the same value resistors. This formula here, you have to have two resistive values. I was going to say two resistors, but that's not completely correct, and we'll deal with that part later. Reciprocal formula, it works for everything. If I have 2 or 3 equal values, I'll use this one because I can usually do it in my head, just like we did with the 100 ohm resistors. This, I can't do that in my head, but this works for everything. No matter what you have parallel wise, this works. Okay. Here's a picture of it kind of being worked out. You notice that they've taken the reciprocal of 150 and added it to reciprocal of 300 and added it to reciprocal of 100. And they've taken the reciprocal of that total and they got 50. Now you may ask yourself, how come that's smaller? You know, in series circuits, you added these things up and you would have had a whole bunch of resistance, but we have a smaller resistance. That's because when we go back to the current thing, when the current's trucking through here, some of them goes this way, some of them goes this way, and some of them goes this way. It's just like if there was 100 of you trying to get into my room and I have 3 doors. Well, you can enter in my room in a parallel fashion. Some of you could use door number 1, some of you could use door number 2, some of you could use door number 3. And since I have 3 doors, just like here they have 3 resistors, you guys can all get in my room faster, can't you? Now, if everybody had to use the same door, then it would take you longer. But since you have 3 doors to come in, then the resistance is less. It's kind of the same thing. If you have 100, 150 of you coming this way and 300, or I'm sorry, if you have, I don't know what the current is, I haven't figured out the current, but a certain amount of amps going this way and this way and this way, you all get in here and do some work a whole lot faster than if you all had to get in line to go do all this one and all this one. This will make a little bit more sense as we go along. Now, there's our total resistance of resistors of equal value. We talked about that a little bit. All these resistors are 24 ohms. And so we have 3 of them, so 24 divided by 3 is 8. I really like this formula, especially in education, because in all the material that I have, and when I did electronics even way back when, teachers like to do this because it's easier for them to grade. So it makes it easier for you, and when I was taking it, for me to figure these out. So you'll see several of the same values, and it makes it a lot easier. So remember this formula here. And product over the sum. Here they would be taking R1 and R2 and figuring out the total value of that, and then they'd take the equivalent or combined value of R1 and R2 and use the same formula to use that one with 3. Like I said, I really don't think I'm ever going to ask you to use this formula, but you do need to know it exists, and we will cover in greater detail on how this works. Like I said, we're just trying to get the basics of a parallel circuit down. I want to make sure you have that before we dig into this math stuff. Okay, and there's a bunch of math there. Let's go flying by the math. Okay, make sure you have this in your notes. We talked a little bit about why. The total resistance in a parallel circuit will always be less than the resistance of any single branch or node in a circuit. Okay, so make sure that you know that. So if you are being asked the total resistance in a parallel circuit and you come up with an answer that is not smaller than the smallest resistance, then you've done something wrong. You need to go back and check it, because if you have 3 resistors in a circuit, a 5, and a 10, and a 15, and you're looking for the total, it's going to be smaller than that 5, or you've done the formula wrong. So that's a little shortcut there to remember. Okay, I think that's it. Remember that we only have we have 1 or more path for current to flow in a circuit, which is different than series circuit. We have changed gears now, and these are our 3 rules: total current, voltage drop, and total resistance. There's that less than any branch resistance again. You can use the reciprocal formula, product over sum, and the circuits in your house are connected in parallel. They didn't even talk about this in the slideshow, but just like in series circuit, remember in series circuits, power adds up. They add up in parallel circuits too. That's the only thing that doesn't change. We'll deal with power a little bit later. Parallel circuits are current dividers. Remember that, I think you might ought to write that one down. I probably should have highlighted that one before I did this video. Parallel circuits are current dividers. A series circuit, if you remember, is a voltage divider, but a parallel circuit is a current divider. The amount of current that flows to each branch of the parallel circuit is inversely proportional to its resistance. That goes back to Ohm's law, applied by branch, and I wouldn't worry about that one yet. Okay, and that's the end of this. Hopefully it wasn't too confusing. We will do some more things to reinforce some of the things we talked about. I do expect you to remember a few of these review things that we looked at. Those are the highlights of what a parallel circuit is. Good luck in the coming days with parallel circuits, and don't forget to hit me up with questions that you have. Okay, All right, thank you.